Let's practice solving quadratic equations by taking square roots together. Just so you're aware, for some of these practice problems, we're not going to get nice answers, so we're either going to round to the nearest tenth as needed, or we're going to write the exact radical instead. Also, if you'd like to download this worksheet for free, you can find a link in the description box below, where you'll also find a link to the PDF for the answer key as well. Let's jump right into it. For number 1, we have the equation x squared is equal to 16. So I'm going to start off by just rewriting it, x squared is equal to 16. And to go ahead and solve this, we need to just isolate this x. So to get rid of that x squared, we're going to use the inverse and go ahead and take the square root. That's going to undo squaring something. And so the square root of x squared is just going to end up being x. And the square root of 16 is going to be plus or minus 4. So there's two answers here. X could be positive 4 or x could be negative 4. Going ahead and writing these separately, we can write it like this and say x is equal to positive 4 and x is equal to negative 4. For number 2, we have x squared is equal to 25. So in order to get this x alone, let's go ahead and just take the square root of both sides of the equation. If we go ahead and do that, the square root of x squared is just going to be x, and the square root of 25 is going to be plus or minus 5. So our two separate answers are going to be x is equal to positive 5 or x is equal to negative 5. For number 3, we have y squared plus 7 is equal to 56. So let's go ahead and just rewrite the original y squared plus 7 is equal to 56. So we're not going to start off taking the square root here. Instead, we need to get that y squared alone, and we can do that by just subtracting 7 from both sides of the equation. That's the subtraction property of equality right there. If we go ahead and subtract 7 from both sides, those 7s are going to cancel out on the left side, and we're going to get y squared is equal to 49. Now that the y squared is isolated, we can go ahead and take the square root of both sides of this equation. The square root of y squared is just going to equal y, and the square root of 49 is going to be positive or negative 7, or plus or minus 7. Writing them separately, we can say that y is equal to 7 and y is equal to negative 7. Both of these solutions work for the equation. For number 4, we have y squared minus 9 is equal to 72. So rewriting this, go ahead and write y squared minus 9 equals 72. Again, we can't take the square root just yet. We have to go ahead and isolate that y squared. So let's go ahead and use the addition property of equality and just add 9 to both sides of this equation. If we go ahead and do that, we're going to be left with y squared is equal to, those 9s will cancel out with each other, the negative 9 and positive 9, and 72 plus 9 is going to equal 81. Now that the y squared is isolated, we can go ahead and take the square root of both sides of this equation. The square root of y squared is going to be y, and the square root of 81 is going to be positive or negative 9. Okay, so writing these separately, y can equal positive 9, and y can equal negative 9. Let's check out number 5. For number 5, we have 3a squared is equal to 27, or 3 times a squared is equal to 27. Before we take the square root, we need to get rid of this 3 and get a coefficient of 1. So let's go ahead and divide both sides by 3. Using the division property of equality, the 3 divided by 3 is 1, so we have 1a squared, or just a squared. And on the right side, 27 divided by 3 is equal to 9. So we have a squared is equal to 9. Now that a squared is isolated, we can take the square root of both sides. The square root of a squared is just equal to a. And the square root of 9 is going to be positive or negative 3. Writing these separately, a could equal positive 3, and a can equal negative 3. For number 6, we have the equation negative 2m squared is equal to negative 128. Let's go ahead and just rewrite this, okay? And we can't take the square root just yet. We're going to go ahead and get that negative 2 away. And so we can do that by using the division property of equality and divide the left side by negative 2 and divide the right side by negative 2. On the left side, those negative 2's will cancel out to make 1m squared, or just m squared. And on the right side, negative 128 divided by negative 2 is going to equal positive 64. Now that the m squared is isolated, we can go ahead and take the square root of both sides. And so the square root of m squared is m, and the square root of 64 is positive or negative 8. Separately, m could equal 8, and m can equal negative 8. Those are the two solutions. Let's check out number 7. For number 7, we have the equation negative 5e squared is equal to negative 500. Okay, so again, we're not going to take the square root just yet. Let's go ahead and get the coefficient to be 1. So let's divide both sides by negative 5 using the division property of equality. Those negative 5 divided by negative 5 is 1e squared, or just e squared. And on the right side, negative 500 divided by negative 5 is equal to positive 100. Now we can just go ahead and take the square root of both sides of this equation. The square root of e squared is just going to be e, and the square root of 100 is going to be plus or minus 10. Writing these separately, e can equal 10, and e can equal negative 10. Those are our two solutions. For number 8, we have this equation of 16p squared is equal to 49. Okay, so what we're going to do is divide both sides by 16 using the division property of equality. And notice what's going to happen here. 16 won't go in evenly to 49. On the left side, we're just left with p squared. But on the right side, we're just going to leave this as a fraction and keep it as an improper fraction whenever you're doing these. Okay, don't turn it into a mixed number or anything. But now that p squared is isolated, we can just go ahead and take the square root from both sides here. And the square root of p squared is just going to be p. And remember, with radicals, if you have the square root of a fraction, you can just take the square root of the numerator and denominator. So the square root of 49 is going to be 7, and the square root of 16 is going to equal 4. So we have p is equal to the positive 7 over 4 and the negative 7 over 4. So written separately, p equals 7 over 4. That's one solution. Another solution is p is equal to negative 7 over 4. Both of these would work for this equation. For number 9, we have 25f squared is equal to 36. So let's see what's going to happen with this one. I think it looks kind of similar to the last example. Okay, so to get f squared alone, we will go ahead and divide the left side by 25 and divide the right side by 25 to get 1f squared, or just f squared. So f squared is equal to 36 over 25. Again, it doesn't go in evenly, so let's just keep it as an improper fraction. And just go ahead and take the square root of both sides here. The square root of f squared is just f. And if we take the square root of 36 over 25, those are both perfect squares. So the square root of 36 is 6, and the square root of 25 is 5. So writing these answers separately, f can equal positive 6 over 5, or f could equal negative 6 over 5. For number 10, we have 10k squared plus 8 is equal to 258. So let's see, 10k squared plus 8 is equal to 258. So we want to isolate this k squared. The first thing we're going to do is take away 8 from both sides, subtract. Okay, when we do that, we're going to be left with 10k squared on the left side. Those 8s will cancel out. And on the right side, 258 minus 8 is going to be 250. Then to get the coefficient to be 1, we can go ahead and divide both sides by 10. If we go ahead and do that, 10 divided by 10 is 1, so 1k squared, or just k squared. And then 250 divided by 10 is going to be 25. And then finally, we're going to go ahead and take the square root for both sides of the equation here. So k is going to equal plus or minus 5. So k can equal positive 5, and k can equal negative 5 to make this equation true. For number 11, we have this 4r squared plus 1 is equal to 325. First, we're going to go ahead and subtract 1 from both sides of the equation. Okay, if we do that, we're left with 4r squared on the left side is equal to 324 on the right side. Next, we're going to go ahead and divide both sides by 4 using the division property of equality. We're going to be left with 1r squared, or just r squared, is equal to 81. That's what 324 divided by 4 is. So now that the r squared is isolated, we can go ahead and take the square root of both sides here. The square root of r squared is r, and then the square root of 81 is going to be positive or negative 9. So to make this equation true, r could be positive 9, or r can equal negative 9. For number 12, we have 8n squared minus 7 is equal to 193. And let's go ahead and see if we can isolate that n squared. So first we're going to go ahead and add 7 to both sides of this equation. If we do that, we should be left with 8n squared on the left side, and on the right side we should have 200. Next, we're going to divide the left side by 8 and divide the right side by 8. Those 8 divided by 8 will cancel out to make 1, or 1n squared, or just n squared. And 200 divided by 8 should be 25. N squared is now isolated, so we can take the square root of it, as well as the right side. So we have n is equal to plus or minus 5. So to make this equation true, n could equal positive 5, or n could equal negative 5. Let's check out 13. For 13, we have this equation of 7v squared plus 1 is equal to 29. So let's isolate that v squared, and we can start by subtracting 1 from both sides of the equation. If we go ahead and do that, we should have 7v squared is equal to 28. Now to get that coefficient of v squared to be 1, let's go ahead and divide both sides by 7. If we go ahead and do so, we get 1v squared, or just v squared, and 28 divided by 7 is equal to 4. And now that we've isolated the v squared, we can go ahead and take the square root for both sides. The square root of v squared is just going to be v, and the square root of 4 is going to be plus or minus 2. So to make this equation true, v could equal positive 2, or v could equal negative 2. For number 14, we have the equation x squared minus 15 is equal to 65. Now to isolate this x squared, let's go ahead and add 15 to the left side and add 15 to the right side. Okay, if we go ahead and do that to both sides here. So if we add 15 to both sides, we're going to be ending up with x squared is equal to 65 plus 15, which is equal to 80. At this point, we can take the square root of both sides of the equation. And on the left side, we're going to be left with x. But on the right side, 80 is not a perfect square. So for now, I'm just going to write plus or minus the square root of 80. Now, if you have a calculator, you can totally throw this in there and then take the square root of 80. And you're going to find out that that's going to be right under 9, right? Because 9 times 9 is 81. So this is going to be right about 8.9 if we round to the nearest tenths place. So as a decimal, we could say that x could equal positive 8.9 or x could equal negative 8.9. However, if you're supposed to write an exact value using a simplified radical, let me show you how to go ahead and simplify this radical if you're not sure. Okay, so if we have the square root of 80, what I like to do here is just separate that 80 into its prime factors so you can see what's going on here. So if we have 10 times 8, and then 10 will break into 5 times 2, 8 breaks into 2 times 4, and 4 breaks into 2 times 2. And once you have the prime factors here, you just go ahead and look for matching ones. So if you have two 2's here, if you multiply those together, you get a perfect square, like 4. And notice that we have another pair of 2's, which are going to make another 4. And then we have this extra 5 over here, right? So it turns out that you have two perfect squares. 4 times 4 is 16, and then 16 times 5 is going to equal 80. And that these two 4's actually can combine to make another perfect square. So 16 times 5 is equal to 80. Right? So if we think about it, the square root of 80 using your radical rules is the same thing as the square root of 16 times the square root of 5. Okay? So the square root of 16 is equal to 4, so we can rewrite the square root of 80 as 4 times the square root of 5. And if you want to go ahead and check that, you can. 4 times the square root of 5 is also about 8.9. Okay, so if we were going to write our answer using decimals, we can use that 8.9 or negative 8.9. But if we're going to write our answer exact, then x can equal positive 4 times the square root of 5, and x can equal negative 4 times the square root of 5. Let's try number 15. For number 15, we have this equation y squared plus 39 is equal to 135. Now to isolate that y squared, we should take away 39 from both sides of the equation, just like this. And those 39s on the left side will cancel out. We're going to be left with y squared is equal to 96. Then we can go ahead and take the square root of both sides. And notice on the right side that 96 is not a perfect square. So we can write y is equal to plus or minus the square root of 96. Now, just like in the last example, if we are looking for just a rounded answer to the tenths place or a decimal, then just throw that into a calculator. Square root of 96 is about 9.8. So we can say that y is equal to plus or minus 9.8, or we can separate and say y is about positive 9.8 and y is about negative 9.8. Okay, it's not exact, but those are its decimals rounded to the nearest tenth. Now, what if we were also looking to take this radical and write the exact simplified version of it? Then we can go ahead and show how this is going to be done. So how does 96 break down? Well, 96, let's see if we have some hidden perfect squares inside of it. And so it's an even number, so we can start with maybe 2 times 48, and then 48 will break into maybe 6 times 8, and then 8 will break into 2 times 4, and this 4 is going to break into 2 times 2, and this 6 will break into 2 times 3. So these are all the prime factors of 96, okay? And let's see if we can find some perfect squares. So matching up this 2 and this 2, that makes a 4, that's a perfect square. Matching another 2 with another 2, That's another perfect square, so that's going to be another 4. Okay. Then we have these extra 2 and a 3, so we're going to just put that on the list here. So if you multiply these all together, we still get 96. But finding these matching 4s, those make 16, which is another perfect square, right? So what's another way we could write the square root of 96? We could write the square root of 96 as the square root of 16, because that's 4 times 4. And these 2 and 3 that are left over here, they didn't really have pairs, so if you just multiply them back together, they make 6. So that hopefully makes sense because 16 times 6 is 96. So we just broke up 96 into 2 factors, one of them being a perfect square. Okay, the square root of 16 is just equal to 4, so we can write 4 root 6. And that's the exact simplified version of the square root of 96. So we can also write our answer exactly, saying y is equal to positive 4 root 6, or 4 times the square root of 6, and y is exactly equal to negative 4 root 6. And if you throw this into a calculator, you'll get about 9.8 and negative 9.8. And finally, for number 16, we have 4m squared minus 107 is equal to 285. Okay, so the first thing we're going to do is try to isolate m squared. So let's add 107 to the left side and add 107 to the right side. If we go ahead and do that on the left side, we should be left with this 4m squared. And on the right side, we're going to have 392. Next, to isolate the m squared fully, let's go ahead and divide both sides by 4. If we do that on the left side, we're going to be left with 1m squared, or just m squared. And on the right side, 392 divided by 4 is going to equal 98. So 98 is not a perfect square, but we can go ahead and take the square root of it anyway and see what happens. Now the square root of m squared is just m, and the square root of 98, let's just keep it as plus or minus the square root of 98 for now. If we go ahead and throw that into a calculator, then we can find out that m is going to be approximately equal to plus or minus, it's got to be a little less than 10, right? Because 10 times 10 is 100. So it actually turns out in a calculator to be about 9.9. Okay, so we could say that m is about equal to positive 9.9 and m is about equal to negative 9.9. Those are the two solutions. Okay, now while those are the approximate solutions, we should also maybe find out the exact solutions in most simplified form, because that's useful to know as well in many cases. So let's take this 98 and see if there's any perfect squares hidden inside here. So to look for those, we can take 98 and try to break this down. We have a 2 times 49. Oh, I think you might already see the perfect square. And then we have 7 times 7. Okay, so inside this 98, notice how we have these matching 7s. So matching 7s are going to multiply together to get 49. And then we have this extra 2 here. So 98 is the same thing as 49 times 2. So we can rewrite the square root of 98 as the square root of 49 times the square root of 2. And since the square root of 49 is just 7, this is equivalent to 7 root 2. That's the most simplified version of the square root of 98. So our exact answer would be m is equal to 7 root 2, and m is equal to negative 7 root 2. So if you don't get a calculator for these types of questions, a lot of times you're expected to write the exact answer with the most simplified radical. And if you do have a calculator, then a lot of times you'll write the decimal answer rounded to some number, like the whole number or 10th or 100th. So hopefully you feel a little bit better about solving quadratic equations by taking square roots. And if you did, please consider giving this video a thumbs up. And as always, keep up the great work, and I'll see you in the next one.